Okay, fine. We start the session. So first of all, I'll introduce myself. Uh, and first of all, very good evening to all. Those who are joining, people are joining now. Okay. So very good evening. And this is actually a live session for the course Basic Thermodynamics, Classical and Statistical Approaches. Which is actually its course code is NOC24CY04, and this live session is about problem solving and also some discussions. If you are having any questions, you can ask. So I will introduce myself first. Myself Akash Gutal. I'm from uh, Jodhpur, from Indian Institute of Technology Jodhpur. I belongs to Indian Institute of Technology Jodhpur. I'm currently third year PhD student in Department of Chemistry. So this live sessions are actually under a part of deliverable in the uh, PMRF fellowship that we get. So we need to teach students from outside IIT uh, nearly 50 hours per year. So this is the part of that same scheme, and NPTEL actually offers gives us chance to teach the students who are joining the NPTEL courses uh, to solve their queries and problems, and to solve the problems in front of them, such that so that they can uh, so that that is helpful for them to solve the assignment problems, weekly assignment problems that this course offer. So what this is the first session, so I will start with the revision. You must have seen the NPTEL videos of the first week, and actually currently the second week is running. So let's do some revision that we have done in the first week. So what we have done in the first week is the first thing that we have done is we have seen the thermodynamic system and variables. Sorry. And then also we have seen the concept of system and surrounding, so such that we have seen the isolated, open, and closed type of system. Also, there are also next we have done the microscopic and macroscopic variables. This microscopic and macroscopic variables. So these microscopic variables are, we know that these are the specific variables about the system, such as the position of the particles that are involved in the system, position of the any unit of the system, systematic position of each and every part of our system. And macroscopic variables are in general, which are comprises of the more collective properties of the system, of the system, such that the microscopic will uh, includes the q p's, the momentum and the positions of the particle, we can say. And macroscopic includes the pressure, volume, temperature, and the number of atoms inside the system. So these are the macroscopic variables. So after that, we also have seen the extensive and intensive variables. Sorry, extensive and intensive properties of or variables. So extensive variables are actually comprises of those property of the system which actually depends upon the quantity uh, of the system, and the intensive variables are those in which the properties does not depend upon uh, the quantity that we take of the system. Then we have seen the concept of equilibrium. Sorry. So what is the equilibrium? Is that suppose uh, there is a one variable inside the system. If it is a constant uh, in time, then we say that that system is under equilibrium. The state variables that we have for the systems, if they remain in the state of uh, in the state of after time t, if they are remaining as a constant, then we will say that it is the condition of equilibrium. And after that, we have learned the zeroth law of thermodynamics. So zeroth law is actually gives us the idea of temperature, such that suppose a body A and B are in thermal uh, suppose body A and B are actually both are in thermal equilibrium with body C, then the body A and B also uh, becomes uh, in thermal equilibrium with each other. After that, we have seen the ideal gas equation. So, which is nothing but we all know from our plus two that PV is equal to nRT, and some gas laws such as Boyle's law and Charles' law. And at the end, we have also seen what is the black body radiation. Okay, uh, these are some revision topic that we have currently have seen, and so let's move toward some specific problems that are involved uh, about these topics. So the problems are actually you can solve it, and you can tell the answer also in between, and I will solve them if you I will solve when I will solve it along with you, so that you can get idea about the problem and how to solve it. So the first question is about which of the following is the state function. Can anybody tell from you? The first is an internal energy, heat, work, and none of the above.
Sir, internal energy is a state function.
Yeah, right. So internal energy is actually state function. It's because its value only depends upon the state of the system. And other two, the heat and work, these are actually vary when you, sorry. So suppose we are having a system which is going from its state A to B, and suppose there are two pathways to go. So heat and work will actually depends upon the path we have chosen, but the internal energy will not change irrespective of the path that we chose. So the answer is internal energy is right. So second question is, which of the following is an extensive property? So we know that extensive and intensive properties. So can you anybody answer this question? So options are enthalpy, concentration, density, and viscosity. It's simple. So the question is, which of the following is the extensive property? So extensive properties are that property which depends upon the quantity of the system inside whatever this component, gas or liquid, depends upon its quantity. So the concentration is actually does not depend upon the quantity, because if you are talking about the concentration, it always remains the same irrespective the things that you take, the amount of the substance that you take. And the density also, as it is mass upon volume, the density also will not depend upon the quantity, because the density of you say 10 gram 10 liter 10 liter of water and 15 liter of water will be the same. It doesn't depend upon the upon the quantity. And the viscosity also a property of your system or substance, which doesn't depend upon the quantity, because even if you take more number of given liquid, more number of liters of given liquid, it doesn't change, the viscosity doesn't change, because it is the uh, it's only depend it's a property itself of that material. So it will not depend upon, sorry, yeah, it will not be depend upon the quantity of the substance. So your answer, the enthalpy is actually, if you take more number as gas, this that enthalpy will be requirement will be higher, or whatever is the quantity will be, enthalpy also changes with the quantity of the your system. So that's why enthalpy is the, we can say, the extensive property. So the next question, identify the intensive property among the following. Well, uh, here uh, more than one answer is also correct. So can you tell which? So there are uh, what are the right answers for this question?
The temperature and viscosity and refractive index maybe.
Yes, these three are actually intensive properties, and the volume is not an intensive property, because the volume, if you take uh, addition of a two volume will be, okay, addition of a two volume will always give you uh, v plus v is 2v. Okay, so it may be 2v or less than 2v, depends. Sorry. It depends. So volume is additive. That's why, and also it depends upon the more number of actual gas take you take the gas, the more volume it will occupy. So the fourth question is so a thermodynamic equilibrium involves. So there are four options: chemical equilibrium, thermal equilibrium, mechanical equilibrium, and all of the above. So can we answer this question? So okay, the chemical equilibrium is actually uh, first of all we will see what is the equilibrium. So if the property does not change uh, within the limit of the observation that has been done on the system, then that we will call as equilibrium. So what we know about the chemical equilibrium is, sorry, yeah. What we know about the chemical equilibrium is, give me 1 second. Yeah. So the chemical equilibrium is actually gives you, uh, suppose there is a reaction A plus B giving rise to C plus D. Suppose the observables of A, B, C, D is, suppose the observable is their concentration, and suppose this observable concentration will not change after uh, the evolution of a time, for all of them, if it does not change, then we will say this is the reaction is under equilibrium, in the chemical equilibrium. So in the place of concentration, it may be any observable pressure and other things, pressure of the gases if it is a gaseous system. So if that observable concentration is actually not changing with time, then hence we can say it's under chemical equilibrium. The thermal equilibrium is actually, we can see, so suppose there are two bodies A and B. So there are two bodies A and B. Initially, they are having A having temperature 0 degree, and B having temperature, suppose 100 degree. Suppose A and B, we connect them, then their temperature suppose become 50 degree, 50 degree. So they attain the thermal equilibrium. So what we can say is that the from 100 degrees Celsius temperature of body B, that heat will flow from B to A, and because of heat flow, the temperature, both of the bodies become equal. So we can say they reach to the thermal equilibrium. And the third one is the mechanical equilibrium. Mechanical equilibrium is such that, suppose there is a particle in our gas, and uh, the force acting on it from various sides, from all other particles and all, and the net force of the all the particles, if it is zero, then we will say that the system is in mechanical equilibrium. So in thermodynamics, suppose uh, we have this piston and gas model. So if it is the system is stationary, the piston is not moving, which means it is in mechanical equilibrium. So all three equilibriums are actually can be considered as thermodynamic equilibrium, or they are requirements of the thermodynamic equilibrium. So your answer should be all of the above. Sorry. So the fifth question is, an isolated system is the system in which there is a not exchange of energy with the surrounding. There is exchange of mass and energy with the surrounding. There is a no exchange of energy and mass with the surrounding, and there is exchange of mass with the surrounding. Can you answer this question? It is simple. So first, uh, can anybody answer this question? It's for isolated system.
Sir, option C.
Yes, there is no exchange of energy and mass with the surrounding. Yeah, right. So because it's as it is an isolated system, so there will not be any energy or in the form of heat or work, and also there will not be any mass in the sense the change of number of atoms, or this is not allowed in the isolated system. So the question number 6 is about, let's say you have two boxes each having 1 atmosphere each, and now if we combine the boxes into one, what would be the final pressure? So there are two boxes which having pressure 1 atm each, and if we combine both, so what will be the answer?
1 ATM only.
Yes, because, and this is also gives you the definition of intensive variable. So intensive variable are actually does not depend upon the quantity. Even if you add these two boxes means two, three, or number of boxes, it will not change. The pressure will not change. So because the pressure is the intensive property of the system. So the next question is, temperature in an ideal gas is produced due to the interaction energy between the gas atoms, the repulsion between gas atoms, the kinetic energy of the gas atom, and none of the above. Remember, it is for ideal gas. Can you answer?
Kinetic energy of the gas atoms.
Yeah, absolutely. Because it's only for the ideal gas. Okay, for the ideal gas, the kinetic energy of the gas atom is actually uh, responsible for its feeling of temperature. So interaction energy between gas atoms and repulsion between gas atoms comes into picture in the real gas. So for the ideal gas, the kinetic energy of the gas atom are actually responsible for the temperature that we see. So next question is the about zeroth law of thermodynamics. So it deals with the conversion of mass and energy, deals with the reversibility and irreversibility of process. State that if two systems each are in thermal equilibrium with a third system, then they themselves are in the thermal equilibrium with each other, and deals with the conservation of energy. So what would be should be the answer?
Sir, option C.
Right. Option C is right. As we know, the Jarrett law of thermodynamics. Suppose there are A, B. This is simplest law in the thermodynamics. Suppose there are body A and B, such that A is in thermal equilibrium with C, and B is also in thermal equilibrium with C. Then what we can conclude from Jarrett law is that A and B should be thermal equilibrium with each other. So, what is the importance of the zeroth law is that it defines temperature. Because it defines temperature, all other laws that are there for in the thermodynamics uh, emerges, or we can say it's a base of these three laws. The next three laws, zeroth law of thermodynamics is the base because it actually defines the temperature. It gives the definition of the temperature. What should be the temperature? So let's move towards question 9. So which is the most fundamental, uh, which does not depend on any other law among the laws of thermodynamics? I'll already gave hint to you. So its answer should be it should be zeroth law of thermodynamics. It does not depend upon any other law because it itself defines the uh, term temperature. Tenth question would be, which of the following will expand more with the temperature? An iron rod, a bottle of water. Third option is ammonia gas, and fourth, a wooden block. What do you think? Which should be expand more with the temperature?
Sir, gas should expand more.
Yeah, absolutely. Because the gas is uh, having the interaction between the molecules in the gases are very low. Because of that, it expands very quickly, and all other substances are, two of them are solid and one is liquid. So the 11th question is, the thermodynamic state of a system at equilibrium is defined by a, first option, set of thermodynamic variables such as NVT, and the coordinates of each molecules of the system can't be defined, none of the above. What should be the answer?
Sir, option A.
Yes. Can I ask why should not be the option B?
Because
Can you give answer for why should not? Because the coordinates of each molecule of the system, once you give you, it is also sufficient to give you the idea about the state of the system. But we are saying that the set of thermodynamic variables such as NVT are only uh, can define the equilibrium.
can we exactly find out the exact coordinate of a molecule?
Yes,
If
that is also technical
if,
reason. And
if it's
also, yeah. Please tell.
yes, sir. If it's in motion, if the molecule is in motion
Hmm.
and not maybe in a in producing kinetic energy, then we cannot exactly define the coordinate of that molecule.
Yes. That's also an answer. And also there is answer we can give according to definition. We are the question asks about the thermodynamic state. So thermodynamic state is always, the classical thermodynamic state is always gives you uh, with the state variables can always be defined in terms of macroscopic uh, variables or properties. It doesn't depend upon the, or it the system's uh, definition. We does not uh, generally we don't give using microscopic properties. So these coordinates of each molecule will be microscopic description of the system. So we are dealing with only macroscopic variables. Hence, the option A is right. You also tell the reason is also right because we can't define the exact coordinate of each molecule of the system at once. And actually, it is not technically possible. Though it is possible using the computers, the simulation that we do, it's possible, but in the simulations, but not exactly in the uh, natural systems. So question number 12 is about, an uncovered glass of water is an example of. It's simple. are an open, closed, isolated, or system cannot fall in any of the above categories. Can you give an answer to this question?
Sir, option A.
Yes, it is open system. According to the definition of open system is that the heat and mass can be exchanged with the surroundings. Okay. So these are 12 questions which are actually these are general discussion about what we have done last week in the course. So can I have one doubt that can I know how many of you are actually doing this course intentionally to give the competitive exams such as NET, GATE, or any exam or something? Can I know about your intention to do this course?
Yes,
So,
sir.
please
Yes,
speak.
sir. Yes, sir. I'm doing this course for my semester exam actually.
Okay, semester exam. Fine. Any other? You can type also. It's okay. Why I'm asking this question is because uh, if you are preparing for any competitive examination, also I can include the questions of that uh, from that examination. So is it okay? Okay, fine. Great. Some people are also preparing for CSIR NET. Okay, yeah, fine. Most of the people are also uh, intended to give the CSIR NET and GATE examination. So fine. So from this question onward, uh, some question I am including from the competitive examination. So these are this will hope this will be helpful for you. So the question number 13. So you can solve uh, as the question appears. So the question number 13 is for three low density gases A, B, C. Pressure versus temperature graphs are plotted while keeping them at constant volume as shown in the figure. Okay, the figure is given and we are asked about what should be the temperature at point K. So can anybody answer this question? If you know how the Kelvin scale of temperature works, you will give this answer quickly.
Sir, absolute zero.
Yeah, absolute zero. So what should be the temperature? Uh,
Minus 73 degrees centigrade.
yeah, absolutely right. Minus 273 degrees centigrade. And this is because we are asked about the low density gases, as you can see in question A, B, C. The pressure versus temperature graphs are given. Okay, while keeping them the constant volume. Okay, this is in question. It is written this. The graph is about the constant volume. So what we know in the uh, by the Kelvin scale is that the graph between PV and temperature is actually for different gases. It follows like this. So this PV versus T graph actually meets as at the absolute 0 Kelvin, which is nothing but 273.15 degrees Celsius negative value. uh, in Celsius. Okay. So this is the reason the point K should have minus 273 degrees Celsius. So this question was asked in the JEE main exam. So next question is for the perfect gas, two pressures P1 and P2. One second. And also because of this volume is constant, as you can see here, the volume is constant, it's given in the question. So this P versus T graph also gives you the same results as we discussed here. So the question 14, the for a perfect gas, two pressures P1 and P2 are shown in figure. The graph shows. So V versus T graph is given and four options about the relation between the two pressures are given. Can you able to guess what is the answer? So I will give one hint. It is related to uh, ideal gas equation. Can easily find out. Yeah, right. P1 is actually greater than P2. So what we can see is, according to ideal gas equation, PV is equal to nRT. And as we can know, the relation between the volume and temperature, nRT by P. So what we can say, NR by P T. So this is actually the slope of this line is comprises the slope is proportional to 1 by P. Right? So the higher the slope means lower the pressure. Right? Higher the slope, lower the pressure because it is inversely proportional. As it is inversely proportional, so the slope is higher as you can see for P2 and lower for P1. So what we have the inverse relation, higher the slope, P2 will be having lower value of pressure. This is also question asked in the JEE mains exam. So question number 15 is 2 liter of gas is at 740 mm of Hg pressure. What is its volume at 760 mm of Hg pressure? Can you find out the answer? The hint for this question, let's wait for someone who is able to answer. So Anubhav Basu, okay, can't. It's okay. If there is issue in mic, you can type. So hint for this question is it's related to Boyle's law.
So 1.947.
Yeah, right. So the answer is 1.9. It's exact if you see 1.9473 liter. So we know it's Boyle's law is P is inversely proportional to volume. And by using this relation, we can write P1 V1 is equal to P2 V2. And using this, suppose we have given P1 is 740 mm of Hg, cross the V1 is 2 liters and your P2 is 760 mmol per kg and V2 we need to find out. So it should be 740 divided by 760 cross 2. So that will give you the answer 1.9473. Fine. So the next question is consider the following graph for Maxwell-Boltzmann distribution of speeds. And it is given the uh, for three different temperature T1, T2, T3. Which one of the following represents the correct order of temperature in the graph given above? So please try to solve this problem. For your information, this question was asked in geochemist examination, preliminary examination. So hint for this question, you use the concept of Maxwell-Boltzmann distribution, how it depends upon the temperature.
The T3 has the highest temperature and T1 has the lowest temperature.
Yes, T3 has the highest temperature and T1 has lowest temperature. So solution for this, we can say we know the Boltzmann distribution, Maxwell-Boltzmann distribution, that so the fraction of molecule moving from velocity v plus dv is actually we can given uh, write as root m by 2 pi kbt into e raised to minus mv square divided by 2 kbt. Right? So this is the Maxwell-Boltzmann distribution that we usually see. So how it depends upon temperature is there are two parts for in this equation. So the first is this factor m divided by 2 pi kbt square root, and second is uh, the factor better I write this in different way, minus m divided by 2 kb into v square. Okay, so there is a second factor is this m 2 kbt, and the first factor is m by 2 pi kbt square root. So what we can say, this is general Gaussian type distribution. So what when you say e raised to minus x square, it's generally called as a Gaussian distribution. Gaussian distribution is like this bell-shaped distribution. Okay, so how its shape changes according to these two variables that we are going to see. So first of all, uh, we can say that this factor, let's say some, if this factor m by 2 kbt, if it increases, one second, my so if this factor increases, then actual this the spread of this dumbbell curve is spread will decrease. So this will become more and more uh, this will become more and more near to one value. So if this factor increases, and suppose if this factor increases, as you can see, if this factor increases, then what it will cause is it will increase the height of this curve. So what we can see, so we can see here the T1 has the highest height, which means this factor is more, and this m by 2 pi kbt and m by 2 kbt is factor is more, which itself gives us the idea it's inversely proportional to temperature, hence the temperature is lower. For the low temperature, these factors will be more having high values. So because of that, we can say that T1 is at lower. T1 is actually low temperature. As we increase the temperature, T2, then T3, we can see the temperature uh, is the spread. As we can see, the spread is actually increasing because when the spread will increase, when this two factor, when this factor will become less, and when this factor will become less, when this temperature will having high values. So your T3 will be at higher side, and T2 is just middle. So your answer should be T1 is the lowest, T2, and then T3. So many of these question related to Maxwell-Boltzmann can be solved having the sense of mathematics, as we can see how this Gaussian curve will change. By changing this, we can also relate to mass and temperature also. So,
Sir, I have a question.
uh,
Sir, suppose I do not know the formula.
mhm,
So can I just by looking at the graph, can we say that 1 by n du by dn by du
mhm.
implements that the number of particle is going on decreasing?
Yes, for
So
increasing, uh,
going on decreasing by 1 by n. So when the graph is at the top, means the highest point of the graph, that means there the number of particle is least. In the second peak, the number of particle is the second least, and at the third peak, the number of particle is last. So the temp and the velocity is almost the means it's going on the same velocity, same direction.
yes,
So we say that as they are moving in almost same as, velocity, but the number of particles are going on decreasing. So the
mhm.
temperature T1 is less because there the number of particle is least and the velocity is same. But in T2, the number of particle is not lesser than more than T1. That's why it's more than T2 and same for the
Yes, yes,
T3.
yes. Also, you can give as we know that when you increase the temperature, your velocities also should increase. And also, as we can see, the uh, higher orders of the velocities can be achieved when you can see is more for in T3 case. So in that sense also we can say that T3 should have higher value, because
Okay,
most of the particles are getting, you can see, most of the particles are getting, in case of T1 you can see the same area, it's covered very less, and for T3 is really large. The velocities of the particle in case of T3 are actually in larger side. Many of the particles are in larger side. So we can say the T3 is maximum temperature, means higher temperature. Sorry. Fine.
okay, sir.
So the next question is about uh, so at 150 Kelvin, the root mean square speed of a gas A, molar mass 30 gram mole inverse, is equal to the most probable speed of the gas B at 300 Kelvin. The molar mass of gas B is. So try to solve. This is related to root mean square speeds of the gas, same as the Maxwell-Boltzmann distribution. This question is also from geochemist examination, I think 2022, in preliminary exam. So we'll extract out first what are the things are that are given. The things that are given are temperature. Oh.
So 60 gram per mole.
60, no. Can you recheck your calculation? So the given things are temperature T, A we can say is 150 Kelvin. The molar mass of A is 30 gram molar inverse, and the things are given. So what question says is root RMS speed of the gas A is equal to the most probable speed of gas B. Param Prem Dawa is answer 40 gram is per mole is right. Correct. We will solve 150 kMa and we TB is given 300 Kelvin and we need to find out MP. So what we know is C root mean square speed is actually root 3RT by M, and C most probable speed would be your 2RT by M. So if we equalize for A and B, we can get 3RT. So RMS speed of A means A is for TA and MA 2RTB and MB. So what we have common, we will be having 3TA by MA, 2TB by MB. So what we can get from it. So 3TA, so MB will be 2TB divided by 3TA into MA. So 2 into, here TB is given 300 Kelvin and TA is given 150 and your mass of A is 30. It's twice, 3 is 10, 4 cross 10 is 40 gram per mole. Mass of it, right? So the next question is here. For maintaining the thermodynamic equilibrium, a system should be in thermal equilibrium and mechanical equilibrium only, thermal equilibrium and chemical equilibrium only. The C option is mechanical equilibrium and chemical equilibrium only. And D option is thermal, mechanical, and chemical equilibrium. So, what should be the answer? We know from our previous discussion what kind of equilibrium involves the thermodynamic equilibrium.
Sir, option D.
Yes, option D is right. We required all three thermal, mechanical, and chemical equilibrium uh, to be there to say to maintain the thermodynamic equilibrium. Even one of them get uh, disturbed, then that equilibrium will not be no more thermodynamic equilibrium. So this is also geochemistry exam question. Next question is the pressure exerted by 10 raised to 20 gas particles, each of mass 10 raised to minus 22 gram in a container of a volume 1 dm cube, and root mean square speed is 10 raised to 3 meter per second is. So you need to find out the pressure from this calculation. Try to solve this question. Small hint for this question is you need to first calculate the temperature because we don't know the temperature in order to calculate the pressure. So we'll start the solving also. Same recipe. So the given quantities that we can see here, number of gas molecules are given, 10 raised to 20, and mass is 10 raised to minus 22. S- e- 1 second, my pen is not working. You solve the question. I just change it. So the volume given is 1 dmq, and RMS speed is given 10 raised to 3 meter per second. So what we need to do is first calculate number of moles that are involved, total number of atom divided by Avogadro number. So it's nearly 10 raised to 20 divided by Avogadro number, 6.022 to 10 raised to 23. So that gives you number of moles, 0.166 into 10 raised to minus 3. Next, you need to calculate. We have mass of uh, so we have mass of one particle, which is the 10 raised to minus 22. Can calculate molar mass. Molar mass we can calculate using individual mass into Avogadro number. 1022 into 10 raised to 23. 60.22. 60.22, it's gram per mole. So this is in gram. So we have RMS speed equation, root 3 RT by M, which you which we can say we need to find out first the temperature. And by PV is equal to nRT, ideal gas law, you can get the answer for the pressure. First, we need to find out what is the temperature. So we can write this thing in terms of temperature. Temperature would be CRMS square by M divided by 3R. Right? That is CRMS is actually given 10 raised to 3 square into mass. So what this we are having here is the mass in CRMS is given meter per second in SI. So we also keep this uh, molar mass also in kg per mole. So this will be 60.22 into 10 raised to minus 3 kilogram per mole. We keep it in SI units. So 60.22 into 10 is to 3 minus 3 divided by 3 into 8.314. So that will give you, if you can calculate, so this will be only 10 raised to 3 will be get 1 10 raised to 3 will be get cancelled, and you will find. Can you calculate? Can you able to get the temperature? If you calculate this, the temperature would come as 2414 Kelvin.
Yes, sir.
Is it?
Yes, sir.
Yeah. So we found the temperature, that is 2414 Kelvin, and we know the volume. Oh, one second. We know the volume, that is 1 dm cube. Oh, 1 dm cube, and temperature, volume, we need to find out the pressure. So we have PV is equal to nRT. So the pressure is equal to nRT divided by volume. So which gives you the N that we have found out here is 0.166. 0.166 into 10 is to minus 3, I think, into 8.314. The temperature is 2414 divided by the volume is 1 dm cube. So this is 1 decimeter cube, which is nothing but 10 dm decimeter is equal to, it's 1 meter. Hence, what we have is 1 dm is equal to 10 raised to minus 1 meter. So we can convert dm cube into meter cube, as we want to keep it everything in SI unit. So that will be 10 raised to minus 3 meter cube. So that will give you, can you calculate this?
Sir, 3331.61.
3331. 3331, is it 3.331?
Yes, sir.
So 3.331 would be, as you can see, the options are not given the way. So you can see the 3.331 is nothing but 1 by 3 into 10 raised to, sorry, into 10 Pascal. This is actually 1 by 3 would be 0. Nearly 333, and multiply by 10 will be 3.331, 3.33. So your answer should be B. Fine. So the next question is about consider the following statements. Statement 1 is at the zero of the absolute scale of temperature, the limiting value of PV denoted by PVM uh, subscript 0 is 0. The statement 2 is the temperature is minus 273.15 is the natural or true zero. So the options are given. Uh, can you guess the answer?
The statement one is true and two is false.
Uh, one is true. Why statement two is false?
Sir, actually zero means zero, not true. What is true zero? It's absolute zero, but not true zero.
Uh, natural or true zero, we
True,
can say minus 273.15 degrees Celsius is actually a natural zero. Natural in the sense
yes, as
uh,
per Kelvin scale.
that's per Kelvin scale. Zero is actually according to Kelvin scale. So this is actually degree Celsius. Uh, it's given. So what do you think? You express as 0 Kelvin or minus 273.15 minus, it's actually the same thing. So the answer is actually A. Both statement 1 and statement 2 are true. Because the temperature minus 273.15 degrees Celsius is just unit is different, but the value is correct. It's we can say it's a true zero uh, or absolute zero. So the Kelvin that we have as a 0 Kelvin is just a change of shifting of one number or unit. So that that is the answer. That is the reason why the both statement are, because PV also we can see we have seen that for the graph PV versus T, PV goes to 0 for all gases. That 0 will be nothing but uh, the limiting value for every gas, ideal gas. So the answer would be 1. The next question is the translational kinetic energy of an ideal gas is. Option A is inversely proportional to the absolute temperature. Option B is independent of the absolute temperature, the directly proportional to the absolute temperature, or directly proportional to the square root of the absolute temperature. This is both questions are from uh, geochemist exam. Any guess?
Sir, it's directly proportional.
Yes, directly proportional in to the temperature, absolute temperature. So C is the right answer. So why it is? Because for the ideal gas, we know the particle is there. Its translational motion is along each direction, x, y, and z. So each direction which will contribute one half kT. So that's why your kinetic kinetic energy will be 3 by 2 kT. So it's directly proportional to the temperature. It's for ideal gas. So the question number 22. Consider the following statements. Statement 1 is the speed distribution of O2 molecules at temperature T is the same as that of SO2 molecules at temperature 2T. And the statement 2 is the distribution of speeds in general depends upon the value of m by t. This is also geochemist exam question. Try to solve. So, as I told earlier, the factors that are affecting the distribution, they are actually the pre-exponential factor and the exponential factor. Only these two things are there that can deviate its distribution, and both are dependent upon. One is dependent upon root m by t, in general m by t. Both are dependent upon m by t. So, which means the value, the distribution of speeds is actually depends upon the value of m by t. But you need to check whether the statement one is correct or not. So we know the Maxwell-Boltzmann distribution as dn by dv 1 by n. Sorry, n is equal to, we have square root of m by 2 pi kbt into e raised to minus mv square by 2 kb. And so once you know what is the variable, that is mass and t, if you know, because these two, the exponential factor and pre-exponential factor, both are depends upon m by t. So if two gases are there, this ratio is same, then their distribution must be the same. So for O2, we have mass is, sorry, m mass of O2 is nothing but 32. Mass of SO2, if you calculate, is 64. So what we have is the temperature T is the same as that of, the speed distribution of O2 molecule at temperature T is the same as that of SO2 molecules at temperature 2T. So this is for temperature T and this is for 2T they are asking. So let's take the ratio. If you take the ratio, then m by T for O2 or O2 uh, MO2 by, so we can write it's as a T, and for SO2 we can write as MSO2 by 2T. So we can write MSO2 as we know, MSO2 is equal to 2 by MO2. That's why uh, 2MO2 divided by 2T will be the same as that of the M by T value for both the gases O2 and SO2 are the same, so their distribution also the same. So what we can say, both statement 1 and statement 2 are the true and statement 2 is the correct explanation for statement 1. Fine. Shall we move?
Yes, sir.
So the next question is the temperature at which the average velocity of nitrogen is equal to that of oxygen at 320 Kelvin is. So this is also a standard question. We can solve it. Uh, Please try to solve it. You have only 30 questions. You can follow. So we are asked about the average velocity of N2 and average velocity of O2. So the average velocity, the formula is square or 8 or T by, sorry, or T by pi m. So what we have is we need to compare these two. So we know the temperatures and masses. So we can say that temperature of N2 divided by mass of N2 is actually equal to the temperature of O2 according to given problem, they should be equal. The condition is they should be equal. So we need to calculate temperature required for N2 gas. TO2 divided by MO2. Oh, sorry. Uh, So what we are having is 320 Kelvin divided by 32 or O2, and this is for 28. So what we are having, its answer is 280. Fine. So consider the following quantities: the concentration, volume, standard electric potentials, and internal energy. Which of the following statements given below are correct? So A is 1 and 3 are intensive quantities, 2 and 4 are extensive quantities. 1 and 4 are extensive quantities, 2 and 3 are intensive quantities, and 1 and 2 extensive, 3 and 4 are intensive. 1 to 4 are extensive quantities, and 3 is intensive. As you can see, the concentration is actually independent upon the quantity that we take. So it should be the intensive property. And we can say the standard electropotential is also independent of the quantity that we take. So it's a intensive property. And we have volume and internal energy. Volume is actually a extensive property, which depends upon the quantity of the substance. And the internal energy is also, we can say, the extensive property, because as we increase the gas volume, number of gas particles, uh, the internal energy will increase. So what we can say, the 1 and 3 are intensive quantities, and 2 and 4 are extensive quantities. So the next question is about, if the distribution of molecular speeds of a gas is as per the figure shown below, then the ratio of the most probable, the average, and the root mean square speeds respectively is. So this is a JEE advanced question. So as we can see in this question, that this distribution that we have for the speeds, the Maxwell-Boltzmann distribution, is exactly a dumbbell curve, which is, as we know, it is comprises of exponential. For that, it's exactly the alpha square. It's exactly Gaussian distribution. When we are having symmetric Gaussian distribution, then what we can say is that the most probable and average speed, these two speeds are become equal because of the symmetry. So that is big, and then because of that, these two are the same, and the root mean square velocity stays the same. In this case, stays the same in the sense, the ratio, the ratio that the proportion that we have for the root mean square will be the same. And because of that, we can say that the option B should be right, because C, most probable and average speed become the same, and it is only in case of option B is only there. And why it is root mean square velocity stays 1.224 in proportion, because uh, it's having higher value than average and most probable speed. It's because we are squaring the speeds and then add and taking a mean, because we are having the proportion of molecules that are having higher speed, that higher speed value, when we square that thing, that will add up, will give you the higher mean than the most probable and average. So that's why uh, this third, the root mean square, will be highest in the three when there is a distribution called exactly Gaussian distribution of the speeds. So the 27th question is, which of the following graph represents the Boyle's law? So the Boyle's law is actually P is inversely proportional to volume. As you can see, the first graph is actually PV is changing, which means PV is equal to constant. This also means PV is equal to constant. So PV is changing here, the first graph, at which is will not be the Boyle's law. And here also PV is changing. PV is must be constant as uh, P increase or decrease. So this in this case also we can see it's valid for this, but it's not valid for this. So the answer should be C. So its PV remains the constant throughout the uh, pressures, value of pressure. So this is the So this is a question about a gas occupies a volume of 2.5 liter at 9 into 10 raised to 5 Newton meter square per meter square, and calculate the additional pressure required to decrease the volume of the gas to 1.5 liter, keeping the temperature constant. So what we have here is, this is also a question about the Boyle's law. So according to Boyle's law, let's write what things are given. So the given things are V1 is equal to 2.5 liter, P is equal to 9 into 10 raised to 5. Oh, sorry, 5 Newton. Sorry for that. Each, and we have delta P we want to answer in this question. What is the change in pressure? Okay. What is change in pressure? Or we can say not change, we need to calculate the additional pressure. And we have volume 2 is equal to 1.5 liter. As we know the Boyle's law, we know P1 V1 is equal to P2 V2. By using this, we can calculate. So P1 is 9 into 10 raised to 5 Newton meters per square into 2.5 liter, 1.5 into P2. So what we'll get for P2 is 2.5 divided by 1.5 into 9 into 10 raised to 5. So that will give you the answer 15 into 10 raised to 5 Newton meter. So the fact that we need to calculate additional pressure we required is P2 minus P1 is 15 minus 9 into 10 raised to 5 Newton is nothing but 6 into 10 raised to 5 Newton per meter square. So option A. Okay, we are having only 10 minutes, so we can do one short question. Yeah. Question number 30 we can do. Calculate the maximum work done in the isothermal expansion of 16 gram of oxygen at 300 Kelvin, occupying a volume of 5 dm cube until the volume becomes 25 dm. So we need to calculate the maximum work done during the isothermal process. So let's calculate this, the maximum work done in the isothermal expansion. As we know, when there is isothermal expansion, the maximum work done is during the reversible process. The process is reversible. The work done can be written as this work done by the gas, hence it is negative N RT ln V2 by V1. Right? So the given things are oxygen, mass, we can say mass of oxygen is, oh sorry, molar, given 16 gram of oxygen is given, so it means it's number of moles. Number of moles are 16 divided by 32, so nothing but zero point 0.5 moles. R is nothing but 8.314 joule per mole. And your temperature will be, and your temperature is nothing but is given 300 kilojoules. So we can find out the work done minus 0.5 into 8.314, because the temperature 300 ln V2 is 25 and V1 is 5, right? Minus 0.5 into 8.314 was 300 into, if you do ln phi is nothing but, uh, calculate ln phi, it gives rise to you, it's minus 207.13 uh, joule. So that is the answer. 2007 was 0.13 joule. It's nothing but, we can say, 2.01 minus into 10 raised to 3. So the answer should be the answer option number 1. Fine. So we will having this session in every week, Tuesday 7 to 9. So this is the last problem, and thank you very much for that attending the session. Uh, we will meet next week. Thank you very much.